All right, good morning. Hello. Are we on? Today is Tuesday, May 19th, and we are beginning the third of the quarter, right? You took midterm 2. So the first third, we went through a lot of definitions about theories and hypotheses and variables. The middle third, we went through a lot about designs and the tools and surveys and observations and experiments. And then this third, we're going to be talking about the results. We're going to be talking about how we describe our results and how we interpret our results and what conclusions we draw. Before I get started, are there administrative questions for me? Not a one? Everything's crystal clear? Oh, yeah.
Do you know approximately what
So when will the written portion be graded? I believe the TAs are trying their hardest to get them done by Thursday. I'm seeing nods. And there's an exam viewing session sometime. So there'll be one on... So this coming weekend is Memorial Day. It's a long weekend. And so there are no office hours and no exam viewings or anything on that Monday because it's a holiday. However, SmartSite is still open. The internet still functions. Your homework is due on that Monday. You've got the homework now. You're going to have the material today and on Thursday. So get that done and get it submitted. I'll try to schedule some office hours maybe on Friday afternoon because I know a lot of you come in and just want to hear some of to get some questions answered. So we will try to make sure that we're available on Thursday and Friday to answer your questions about that homework because it's a long weekend. And you'll want to get that done beforehand, right? And just get it submitted and taken care of. So there will be announcements about the exam viewings and when that exam is done, but we're trying our hardest to get it done by Thursday. We try to have a week turnaround. Other administrative questions? Okay. All right. So we are going to start talking about data, and we've been kind of talking about it, but we're going to flesh that out some more. Talking about data, talking about interpreting and our conclusions. To start with, I want to gather some data from you guys that we're then going to analyze over the next 3 weeks. So I have a demonstration that I want to do with you where I'm going to try to randomly assign you to 2 groups. That's going to mean that. So why do we randomly assign people to 2 groups or to participants to different groups? So that those groups are considered to be equal to begin with, equivalent, that there would be no systematic differences between the 2 groups to start with. So I'm going to give you a moral decision to make. It's a cartoon moral decision, but it is a moral decision to make. Cartoon lives will be in your hands. So I'm going to randomly assign you to 2 different conditions. The different conditions will have different information. There'll be a different choice to make. So we'll be able to see, is there a difference between these 2 choices? Do the same people make different decisions in these 2 different contexts? Got where we're going so far? So I would like to include another variable about your moral decision making, what might influence your moral decision making. And I think what I'd like to include this quarter is growing up, were you taught to be good because there was like a higher power who'd written the rules and was watching you? Or were you taught to be good so that you felt good inside and because it was the right thing to do? Does that make sense? Sort of if I said on a scale of 1 to 10, was it, that there was a higher power who was watching you and that's why you have to be good? Or was it 10? It's just down to you and just to be good for your own sake. Could you answer that question? No? So, yeah, if it was both, if it was balanced, you'd be a 5. Okay? So sort of if you thought about it on a continuum of it was entirely because there was a higher power that was watching you and that you had to follow the rules, or entirely because that's it's to be good to yourself. But if it was a mix, you'd be somewhere in between. All right, so if I say 1 and 10, I should really say 1 and 9, and then 5 is the midway point, right? Let me do that. So we're going to gather that data, and then we're going to look at a whole bunch of different ideas around data. So all right. Are you ready? Yes? So to begin with, you're all in the same situation. So let's all read this setup. And this is really badly timed with the train wreck last week. A trolley is hurtling down a track, out of control. There are 5 innocent bystanders tied to the track in the path of the trolley. You can save them. These cartoon lives are going to be in your hands. All right. If your birthday is on an even day of the month, we agreed that would be a pretty good way of randomly dividing you. If your birthday is on an even day of the month, I want you to keep your eyes open. If your birthday is on an odd day, close them. Please don't peek. I will show you guys all the information at the end, so you can see the 2 conditions at the end. So odd day birthdays, here is your decision. Here is the information that you are being given, and then I'm going to make you... What? Oh, I'm so sorry. Did you all just have your eyes open? Okay. Well, okay. So, even day people, you've got your eyes open. Odd day, close them. Right now. Here is your information. I'm going to show it to you all at the end, but here is your information. All right, you've got the information in your mind. I'm going to ask you to make a decision about this in a minute. Okay? Go ahead and switch. Odd days, keep your eyes, or open your eyes. Even days, close them. Here is your information. All right, do you see your decision? Do you see your information? Great. Go ahead and get out your clickers and let's gather that data. So first off, just tell me, which group were you in? Were you in the first group or the second group? The first group that saw the first piece of information. The group that saw the first piece of information, or the group that saw the second piece of information? Which group were you in? All right, I'm seeing a bunch of you there. Is that all of you? Okay. So I'm going to now ask you the decision question. Come on. Seriously? What? What do you want? Okay. So here's the decision. So you're all making the same decision. All right, and I'm seeing a bunch of you there. Is that all of you? And I'm going to go ahead and stop that, and we'll move on to the next question. Oh, sorry. This is a numerical. Sorry, I'm sorry. I'm stopping it. So this is a numerical one. So because we want a number between 1 and 9, and your clickers only go up A, B, C, D, E. So you have to like push the blue button, and you get into like oldie timey texty, and you have to like over, up, down, and then send. Do you see what you're doing? Press the blue button. Oh, if you're using the one version, it won't work. But press the blue button, and you should then be able to enter numbers by going up, 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 up. Are you seeing it? You can find a number between 1 and 9. All right, and I'm seeing most of you there. Okay. And I'm going to go ahead and stop that. All right, so we've gathered some data that we're going to explore for the remainder of the quarter. What are the questions that? Oh, let me show you what everyone saw. So you all started with the trolley is hurtling down the track. You all started with the trolley is hurtling down the track. Okay, someone who was saw the first group of information, go ahead and describe what you saw.
So basically, you would have to push a fat guy off of the bridge to stop the train.
Okay, so there was a fat guy on the bridge with you, and if you pushed him off, then he would stop the train. How about the second group? What decision did you get to make? No one's going to admit being in the second group now.
Would you choose saving one person on one track or 5 people?
And how did you have to make the choice?
By choosing a track.
So you happened to be standing next to the switch, and you could pull the switch, pull the lever, and the train would be diverted to a side track where there was only one innocent bystander tied to the track. Oh my goodness, it's just gone blue. All right, so while my computer restarts, what I want to do is to move on to something on paper anyway. So we're going to back up a little bit and talk a little bit more about those factorial. Oh, so hang on a second. I'm a little distracted because of the computer. So those were the decisions. So what's the big question that you want to ask of the data that we just gathered? We've got 2 groups. I asked each group, would you save the 5 people? And you answered on a definitely yes to definitely no scale. What is the question that you could ask from that data? What question could that data answer? So what's the likelihood? Do those 2 groups answer that question the same? Right? So what word would you give to that variable that you either had to push someone off the bridge or you had to pull a lever? What's kind of the salient? What label would you give that variable? So it's about decision making, but you're all making the same decision. What is really varying? Well, but there was all 1 person versus 5. The variable was you had to put your hands on someone and push them, or you had to pull a lever. So it was morality, but again, in either case, you're killing 1 person. You are either allowing 5 to die, or you're killing one person. So that's not a variable. So the method, so the lever or the pushing, but how would we, what if we backed up a little bit? From
Because you're saying pushing you physically are in charge.
Oh, so it's sort of physical involvement.
Well, the lever, you're not technically putting them in there. You just happen to be there.
So it's personal involvement, how close you are to that person that you're going to kill. Yes, so like proximity to the one innocent bystander. So in close proximity would be you're actually putting your hands on their back and pushing them. And more distant proximity would be you're pulling a lever. Do you understand why that is the variable and killing one and saving five is not the variable? That the variable has to do with your proximity to the one person. That what we varied there was whether you were actually standing next to them and had to put your hands on them and push them, versus you were sort of a little bit removed and you could just pull a lever and you didn't have to touch the one person that you were going to be sacrificing. Because in both scenarios, you were sacrificing one to save five. But the difference was how close you were to the one person that you were going to sacrifice. Oh my goodness. Okay, I'm going to just leave it for a second. And we're going to, so the big question we're going to ask is, I wonder if proximity affects the moral decision, the decision that these people make. Because we randomly assigned you, so if both groups had been given the same decision, we would expect you to answer it really similarly. That this would be the overall morality of this group, the overall decision of this group. Because we gave you different information, the variable that we varied was this proximity to the person to be sacrificed. We can ask whether you answered that question differently. What do you suspect? You suspect that there'll be a difference? Which group will be more likely to save the 5 people? So with the lever, with the far proximity, we suspect that group would be more likely to save the 5 people and kill the one person, and the close proximity you'd be less likely to. I think that's a really good prediction, a really good hypothesis about how those variables are going to be related to each other. And then we can also bring in that 1 to 9 scale of were you raised with sort of a higher power that you have to be good because someone's watching you, or were you raised more with you have to be good to be true to yourself, and see if that influences your decision making in this situation. I'm going to pull out that data in just a second if my computer comes back on and talks to me nicely. But for right now, what I want to do, so I wanted to gather that data so that I had a chance to pull it out and show it to you. So while I'm pulling it out and showing it to you, I've got some other things for you guys to do. So what I want to do is back up a little bit and talk about factorial design. So the last part of the experiment, or the lectures on experiments, we introduced the concept of factorial designs. What does a factorial design piece of research look like? What makes it factorial? Multiple independent variables. So more than one predictor variable, more than one independent variable. When we are looking at factorial designs, we look at both the main effect of each variable on its own, yes, and we look at whether or not the variables interact. Are you remembering this? Yes? So I wanted to go through some examples. So this is just made-up data, made-up example, based on the idea of the effect of instructions and presentation rate on recall. So if I invited you all into a lab and said, I'm going to show you some words, and I'm going to ask you to remember them, and then I had randomly assigned half of you to be told, while you're reading the words, while you're trying to remember the words, pull up a mental image, create a mental picture that goes with that word. And I randomly assigned the other half of you to say, while you're trying to remember these words, just go ahead and repeat them in your head. So we've got imagery instructions or control instructions. Within each of those groups, I've also randomly assigned half of the trials to be presented at 2 seconds. So there are words coming at you every 2 seconds. And half of those trials to be at every 4 seconds, where there are words coming at you every 4 seconds. So we've got 2 predictor variables and 1 outcome variable. What did I say the outcome variable was going to be? Recall. And the 2 predictor variables are speed of presentation and imagery instructions. So let's say we did that and we got this data. So we've got our 2-second group and our 4-second group. And we've got our imagery group and our control group. The first thing we do is we look for main effects. To look for main effects, we say, oh, let's ignore the presentation rate and just focus on the imagery instructions and the control instructions. So if I look at all, if I just had all of those people who had the imagery instructions in one group, what would be the average between of all of the people that saw imagery instructions? That's easy, right? 22 and 22, average is 22. How about the control group? What was that? So 14 is the, so if we collapsed across the levels of the presentation rate, so I've said assume that the group sizes are equal. Also assume that if there's a difference of 3 or more, that means it's a real difference. These groups are different. So is there a main effect of instructions? And which group did better? There are only 2 groups. So if they're different, one's better than the other. So the group using mental images recalled more items. That's what that says? How about if we collapse across the main effect of the other variable, main effect of presentation rate? What do we get if we average 22 and 14? 18. What do we get if we average 22 and 14? 18. Is there a main effect of presentation rate? No, there's no difference. And actually, they're exactly the same, which would be really unusual. But so presentation rate did not affect recall. That would be saying that there's no main effect of presentation rate. To look for whether there's an interaction, do you remember what the opposite of interaction is? It's either they either interact or they are additive. The easiest thing to do is to graph it. Visualizing your data is a really good practice. Creating your own graphs is really good practice, way different from seeing someone else's graphs that someone else has created. So I've put out the axes for you where we've got our outcome variable on the y-axis. On the tests and things, the outcome variable is always on the y-axis and it's always labeled. So looking at the graph and just looking at the label they use there and asking yourself, is that a good label to write in as the label for the outcome variable? It's probably a really good idea. Use the information that you're being presented. So we've got the outcome variable on the y-axis. On the x-axis, I needed to put one of the predictor variables. We've got two predictor variables. It's a little arbitrary as to which one I put on the x-axis and which one I put sort of as we're going to put as x and x and a box. I chose to put the 2 second to 4 second on the x-axis because that is a continuous variable, whereas the imagery instructions and the control instructions is a categorical variable. And so this will allow me to draw a line, because it makes sense to say, as I go from 2 second presentation rate to a 4 second presentation rate, that's along a continuum. But it's a little bit arbitrary as to which one you put on the x-axis and which one you put in the legend. So let's do that. So where does imagery 2 seconds, where does my data point go? Up there. How about imagery 4 seconds? Same place, and I'm going to connect those lines. In control 2 seconds, goes right there. Control 4 seconds goes right there. And I'm going to connect those two lines. What's the rule of thumb that we're using for whether or not there's an interaction? Not if they intersect, if they're not parallel. So we ask, are they parallel? Are those two lines parallel? Yep. Therefore, additive. No interaction. We're going to hear a word like regardless of. So the group using imagery techniques recalled more than the group using control techniques, regardless of presentation rate. So how about the imagery instructions? Improved recall, comma, regardless of presentation rate. So let's try another one. What if I gave you the data okay? Go ahead and create your own graph around that piece of data, please. All right, have you got it? What does that graph look like? Have you collapsed over the levels of the other variable? Done your averages? Written your main effects and your interactions? All right, let me see if who's got one that they are willing to show me. You guys are all hiding now. May I take yours?
I haven't finished.
Oh.
Sorry. No.
That,
I have a graph.
okay. Let's. All right, so what have we got here? We've got 2 seconds, 4 seconds, and they're right on top of each other. Is that what the graph looks like? Is that what everyone got? Yes? And we've averaged across, so is there a main effect of imagery instructions? May I write on your paper? So, what would we say? Well, let's just focus on the main effect of imagery instructions. So imagery instructions did not affect recall. How about the main effect of presentation rate? We're assuming that if there's a more than 3-point difference, that it's real difference. So at 2 seconds, on average, they remembered 14 words. On 4 seconds, on average, they remembered 22 words. So that's a real difference. So how might we write that simply and concisely? So 2-second rate was like this. 4-second rate was like this. So the presentation rate. So it's kind of the slower presentation rate. One word every 4 seconds improves recall. Now, I'm using very causal words here. Am I allowed to do that? Improves, affects. Am I allowed to use causal words here? Yeah, because both of my variables are independent. Both my predicted variables are independent. Therefore, they're both going to be, we're going to be able to draw a causal relationship. Is there an interaction? Do those look like they are the same? They're parallel. So there's no interaction. And we would have the same sort of sentence, wouldn't we? That the presentation rate improves recall regardless of instructions. We would just flip those two around. Let me give you another one. Does someone have them printed out? Oh, never mind. Okay. And let me return your paper. All right, and go ahead and graph this and analyze your main effects. What does this one look like? All right, have you got those done? Let me come and pick on this side of the room. What does that look like? How might we interpret that? I know, it would be much more comfortable if I just stayed in the front at the stage, right? Creating your own graphs is a valuable skill. It's a valuable way of exploring the data. May I borrow your notepad book? All right. So what does this data look like? Have we got it there? Is that what the graph looks like? Yep. Was there a main of, oh look, yes, perfect. So when we collapsed over the imagery instructions, may I write on your notebook? Yeah. So is there a main effect of instructions? So if we collapse over instructions, we get 20 versus 16, and that was a 4-point difference. We said assume that if there's a 3-point difference that it's real. Now, in a couple of weeks, we'll have a test that tells us whether it's real, but for right now, I want you to practice these concepts. So I'm just going to give you this rule of thumb. So there is a main effect of imagery instructions. So we'd say, it's imagery improves recall again? Improves recall. Is there a main effect of presentation rate? Yes. So the slower presentation rate improves recall. Is there an interaction? So we're looking at this and saying, are these lines roughly parallel? And that's a good rule of thumb. But again, in a few weeks, we'll have a definitive, here is the test that tells us if there is an interaction. Another way of thinking about this is to subtract those 2 points and subtract those 2 points. And then what's the difference of those differences? That's another way of thinking about your interaction. And if the difference of your differences is roughly 0, then there's no interaction, because that would mean they were parallel lines. All right. How about let's get an interaction going? What if our data looked like that? What do we see then? Thank you very much. May I borrow your paper? You're never going to sit on the edge again, are you? Have we got it? Is that what the graph looks like? Yes? Is there an interaction? Yes. Those lines are not parallel. In fact, they even intersect. That's not necessary for it to be an interaction, but that certainly would imply that there wasn't, that those lines are not parallel. When we have an interaction, that sort of overshadows the main effect. So let's focus on how we would write this interaction. In this case, 3 of the data points are the same, right? And 1 is different. Yeah? So it might be a good thing to really pull that out and say, well, let's remind ourselves, what's the basic sentence that we use to interpret an interaction? May I write on your paper? So an interaction, the basic sentence is, the effect of variable A differs depending on the level of variable B. Now, you're being asked to write a lot of interpretations in your homework this week, and I've given you sort of these template sentences, and you just need to work with those and plug in the right, if it's greater or stronger or what the labels are. So we might say the effect of imagery instructions differs depending on the speed of presentation. So that's a good first sentence. And you see how I've substituted speed of presentation for level of variable B. At fast, so now we need to go drill right into the variable levels. At a fast presentation rate, 2 seconds per word. What was the effect of the instructions at 2 seconds? Did the imagery instructions make a difference then? The imagery instructions improved recall. However, at the slower presentation rate, 4 seconds per word, what's a nice simple way of saying that? Yeah, the instructions made no effect, had no effect, or yeah. So At a fast presentation rate, the imagery instructions improved recall. However, at the slower presentation rate, the instructions had no effect. So whenever we have a set of data, we ask whether there's a main effect of each variable. Thank you very much. And we also ask if there is an interaction. There can be any pattern of those, right? I showed you main effect of one, main effect of the other, interaction. Oh, there can be main effects but no interaction. And I will leave you for this to sort of think about this. If that was your data, actually that would be a good challenge for you guys to kind of extract that out. Is there an interaction? Clearly there's an interaction, right? And actually if you went and worked out what that data is, you would prove to yourself that there were no main effects of either variable, but there was an interaction. But I'm going to leave that for you to do. All right, questions about those main effects and interactions? We good to go? All right. So let's continue our discussion. Oh my God. What? What? Please? Okay. Nobody breathe. So we're going to pick up with descriptive statistics, and we're going to go and describe that data we just gathered on the trolley. And we are building towards this analyzing our results and interpreting our results. But we're going to start really slowly. We're going to start with very basic descriptive statistics. This might seem really slow and really like review. That's great. Don't worry, it'll get faster over the next couple of weeks. So first off, I'm just going to do some preliminaries about what variables are and what they aren't. And then we'll talk about categorical data, and then we'll talk about continuous data. You see, you guys have been practicing categorical continuous all quarter long, and now you absolutely know what that means and are ready to hear why it's such an important part of our research design. So variables must vary, right? If they don't vary, it's a constant. We have predictor variables that could be a pre-existing characteristic, gender, education, experience. It could be a subset of predictor variables, an independent variable where it's under our control. And we have outcome variables, which is our response, our measured, our outcome. We call it a dependent variable when we run an experiment because we hope that it depends on the level of the independent variable. Review, right? So when we start talking about statistics, we are going to start using some mathematical notation. We'll use letters like X and Y to represent the variables or the sets of the data. So that data that I just gathered from you, you all told me which group you were in. So we could say, let me pick on you. You were participant 1. And so what group you were in was variable X. So your data was X sub 1 of what group you were in. And then your decision, whether you were going to save the 5 or not, we'll call all of that data column variable Y, and yours is Y sub 1, and yours is Y sub 2, and yours is Y sub 3. So we'll use X and Y to represent the variables or the sets, and we'll use subscripts to represent an individual score within a specific group. So each of you gave me 3 variables. So you gave me an X and a Y and a, I don't know, let's say W. And so each of you have, there were 3 columns of data. We used the letter N to indicate the number of observations. So the sample size, the number of observations. Uppercase N means that it's the total group. A lowercase n we use whenever we're looking at a subset. So if I said there were uppercase N 273 respondents, and then in the group that had close proximity, I'd say lowercase n, there were this many people in that group. When we measure variables, we've either measured them categorically. This is naming, or they might have an order, but they're still just groups, they're labels, they're words. Or we have measured them continuously, and we're going to lump interval and ratio in here. I know I told you you'd never have to remember those words again. We know that we're being a little bit naughty about having our interval ratio data in here, but it allows us to do interesting things, and we make sure that we are being sort of humble about that assumption. And those vary in quantity or amount. They're numbers along a scale. They are continuous. We are starting a whole unit on statistics. We're going to start today with descriptive statistics, where we describe the actual data. We describe the data we gathered. We are quantifying those observations. But it's not so much that particular data set that we're interested in. I'm not so interested in whether your birthday was on an even day or an odd day. I could easily have flipped you guys. In fact, I nearly did. I'm more interested in the whole population. And those, we will then talk about inferential statistics, where we take our specific sample and we say, given that kind of random noise error that we know we get in a sample, do we think that these findings apply to the whole population, yes or no? And so we will then start talking about inferential statistics, where we're trying to make inferences about the population. Your choice of statistics is entirely just like a flow chart. There's nothing creative about choosing your statistics. So you first ask, were my variables measured categorically or continuously? So you need to, you just, is my predictor variable categorical or continuous? Is this outcome variable categorical or continuous? That gives you most of the information that you need as far as which statistic you're going to choose. There's one other question. If your outcome is continuous, you ask, is my population normally distributed for this trait? Normally distributed. That's statistician's secret code. A lot of characteristics are normally distributed in the population. If I was to ask everybody to come down here and join me and line up by height, and that if you found someone who is exactly the same height as you, stand behind them. And if I took an aerial photograph from up here, so we've got height going across our x-axis here, and then we've got the tops of your heads, right? You can see that. Those are the tops of your heads. And so we've got a few people who are really short, and then a whole bunch of people who are of average height, and then a few people who are really tall. And so we say that this is normally distributed. What's this shape? A bell curve, right? You've seen this idea before. And we think that we assume that many characteristics in the population are normally distributed, because that then allows us to make a lot of inferences and decisions. And we'll talk about the normal curve a lot. So the normal distribution. So we could have said line up by height. We could have said line up by IQ. We would expect to see a similar distribution. So we see this lovely bell-shaped curve, and we call it the normal distribution. Often we don't put a y-axis on there, but it's, how many people. It's a frequency distribution. So it's showing that there's just a couple of people under here, and that there are a whole bunch of people under here, and we're all pretty much clustered around the average, the central number. And then there are a few people who are above the average, and a very few people out there on the end. So when you are choosing your inferential statistic, you ask yourself, is my predictor variable categorical or continuous? Is my outcome variable categorical or continuous? If your outcome variable, if you're in this group, the categorical and categorical predictor, continuous outcome, you also need to ask yourself, do I assume that my population is normally distributed? You might say, no, I don't think it is, or you say, yes, I think it is. And so these are going to be, we're going to fill this chart in with 4 different types of descriptive statistics and 4 different types of inferential statistics. So let's start talking about when we've got categorical outcome variables. We've also got categorical predictor variables. Let's start talking about that row on that table. So the levels are going to differ in quality or kind. They're being measured categorically. If you've only got one variable, there's not much you can do. It's not very interesting. You can tell me how frequent that is in your group. When you've got more than one variable, a predictor and an outcome, it becomes more interesting. So let's have a look at what we can do there. So to go back to an example we talked about last week, the survey in Psych 1, were you sober the last time you had sex? So if we just look at one of those variables, were you sober the last time you had sex? We've got the group that said yes and the group that said no. And we can just present that as frequency. I told you it was going to start slow. We could graph it as just a count of the frequency, how frequently occurring is this. But there's really not a whole lot else we can do with that. So let's move on and make it a little bit more interesting. If we've got more than one variable, we start by laying out our variables in a contingency table. So the predictor variable in this case was your alcohol status, and the outcome variable was whether you used a condom. So we've got our 2 variables. They're both measured categorically. In this case, they both happen to have 2 levels, but they could have more than 2 levels. We've got the levels of alcohol status, and we've got the levels of condom use. We then fill in how many people fell into each of those groups. So we've divided our total group into 4 possible groups. And we called, so these are the cells, so that's filled in with that data. Let me switch to scribbling on it. So this was 65 and 22. So here are our cells. We then start totaling our margin values. So we've added across here and across here. You guys are going to need calculators. So how many of the whole group used a condom? Is it 384? And how many of the whole group didn't use a condom? 87? And what was the total group size? 471? So our capital N, our total sample, is 471. So what would be maybe some... So we've said that sort of that high level, if we just look at one variable, were they sober or not, we could just count the frequency. But that's very dependent on, it's 402 out of 471. If we did this study again with 4,000 people, we wouldn't see the same numbers here. So how can we describe that so that it is more standardized? Percent. So 402 is what percent of 471? We're going to take 402 and we're going to divide it by 471. And we find that that is 85%. So this was for males who regularly use condoms. Oh, yes, so 85% of them said that they were sober the last time they had sex, and 69 divided by 471, 15% said that they were not sober the last time they had sex. So you might start your interaction, start your results section with that quite large overview. This group, N is 471, 85% of them said that they were sober the last time they had sex, and 15% said that they were not sober the last time they had sex. Let's do the same for whether they used a condom. So what do we divide 384 by? 471. And what do we get? Should we do 82? And then 87 divided by 471. So 82% of them used a condom. These are males who regularly use a condom. I guess that makes a lot of sense. So we can start with that kind of overview, the big picture of summing our margins and calculating the percentages, very much like the main effects that we were looking at with the continuous outcome, where we're saying overall what's the frequency of this variable, the levels of this variable, and what's the frequency of the levels of that variable. But we also want to drill deeper into the individual cells. So in this case, which is the predictor variable and which is the outcome variable? Sobriety, so alcohol status is the predictor, right? So does alcohol status predict your condom use? So let's focus on sort of going across. Of those who were sober, what percentage used a condom? So we're going to kind of go across this way. What are we going to divide 337 by? Do we divide it by 471? No. Of the group that was sober, so we want the total sober, 402. And I think we did this before, that's 84%, and then 65 is 16%. And for the not so sober, what do we divide the 47 by? 69 equals So now that we've turned it into percentages, we can more easily compare 84 to 68 because they're on the same scale. They're out of 100%. Instead of looking at 337 and 47 and having to take into account 402 and 69, by making a percent, by making that ratio, we've turned them onto the same scale, and so we can easily compare them and say, man, there seems to be a really big difference in our decision making depending on alcohol status. Questions about that? So we lay out our variables with the levels, that creates our cells and our margins. We sum across the margins, we calculate percentages because we're dealing with categorical predictor variable, categorical outcome variable. So in text we might start with that overall sentence in this survey, and we'd give the sample size, n equals 471, 81.5% reported having used a condom the last time they had sex. So that's just what percentage used a condom. 84% of those, and then let's drill into those cells. 84% of those who had been sober, lowercase n equals 402, and 68% of those who had not been sober, lowercase n equals 69, reported having used a condom the last time they had sex. So we start with the kind of the blanket statement, the overall, and then we drill down into the different groups. So we can report that in text. We can report that as a graph where we're reporting the percentage who used a condom for the two different groups. So our predictor variable is along the x-axis and our outcome variable is along the y-axis. And for those categorical variables, that's pretty much all we can do. Continuous outcome variables, way more interesting. So one of the first things that we can do with a continuous outcome data set is just kind of dumb it down into, we can dumb it down into categories and do the same thing that we did with the, oh, I've deleted it. So you're used to seeing this a lot with your grade on an exam or your grade in a class, where your grade was based on, a pretty fine continuous variable of how many points you scored. But then it makes sense to just group it into A's and B's and C's and D's. And so you're used to seeing this, right? This sort of histogram of a grouped frequency distribution where we've taken this beautiful continuous variable and we've dumbed it down into categories. But far more interesting is to leave it continuous. And then we want to look at two aspects of that continuous variable. So when we are dealing with continuous outcomes data, we want to identify what is the measure of central tendency, and we want to identify what is the variability in this group. Measures of central tendency. Central tendency is the typical score. It's the score around which the others cluster. We've got three ways that we can estimate this. One is by calculating the mean, the average. What was the average of this score? So it's the central tendency. Another way we can calculate the central tendency is by calculating the median or the middle score. And we'll talk about when we use that. And then the last one that estimates our central tendency is the mode or the most frequent score. Very conveniently, these words all start with the letter M. They all go together. They're all trying to estimate the same thing. The mean, the median, and the mode are all measures of central tendency. So we are the mode is probably the least useful of those three. The mean and the median are both quite useful. The difference is whether we think that our data is normally distributed or not. So how do we? So let's look at how we calculate those and when we use those. So a little bit more on notation. We're going to use the sigma, uppercase sigma, to mean sum of. Add up everything that comes after this. So the arithmetic mean, we will abbreviate it either a capital M or an X bar. It's impossible to do an X bar on SmartSight, so we'll use the capital M to stand for mean. And the formula is sum up the scores, sum up the X's, and divide it by N, the number in that group. So sum the observed scores divided by the number of scores. So in your data, so this is the data that we just gathered. We've got your clicker ID number there. Just different people have a different clicker ID number. And then there's question 1, which was, what group are you in? And so those should be A's or B's, first group or second group. And then there was question 2, which was, would you save these 5 people? And I had you answer it on an A, B, C, D, E. So it's going to be hard to do anything mathematical with that at the moment. But what could we change that to? 1, 2, 3, 4, 5, right? So we could then look at the average of whether you were a 1, a 1 or a 2. And then we gathered data we gathered numerically, which was on that scale of 1 to 9. What's how were you raised? What sort of moral reasoning were you raised with? So we could right now calculate the average of that scale of 1 to 9 and describe, of the whole group, this is what they thought. I'm seeing some interesting things there. So there's a -4 and a -2. We asked to put this on a scale from 1 to 9. What should we do with a -4 and a -2? Is that valid data? It really isn't, is it? So we would want to make a very fixed rule where we're going to clean up our data. Let's go ahead and clean up the, I'm just going to sort by that question 4 so that we can see the range. So anything that's out of the 1 to 9 range, we're going to delete. We're allowed to clean up the data as long as we have a rule and we apply it consistently. If we say, oh, if I see that this one doesn't fit my hypothesis, I'm going to delete it, that doesn't work. But you can certainly say, the ones that are outside the range, I'm going to just delete. Now that 0.7, it was, we could think that it was maybe a 7, but we don't know. So here's our 1s and 2s and 3s and 4s and 5s and 6s and 7s and 8s and 9s. And then here are the ones that no vote, that didn't vote. So let's just clear those. So to calculate an average, we first start by adding those all up. Oh, we're going to need to know how many there are as well, aren't we? So we add them all up, but we need to know how many there are. So I'm going to ask Excel to count how many people answered that question. So 243 valid responses. And then what's the average? We take that and we divide it by, so the sum divided by the count. When we asked you if you were raised with external authority or internal, be good, true to yourself, the average of the group was around a 6. So we would summarize the central tendency, in this case, by calculating the average. So here, if those were your scores, you would add them all up, you would count how many there were, divide the sum by the count, and you end up with the number that is your average score. We use the median if we think that we've got skewed data, if we think we've got outliers. So it is the middle score. We're going to abbreviate it as MDN or Q2. Honestly, we're not going to talk about it a whole lot because there's not much more that we can do with it if we have skewed data. So I'm just going to make sure that you're aware of what it is, and then we're going to kind of move on. So it's the score that divides the ranked data in half. 50% are above it, that score, and 50% are below that score. So you start by ranking the data, putting it all on in order, and then you kind of fold the people. I mean, think about it. If you wrote them all out on a piece of paper and then folded the piece of paper in half, what's the score that is right on the crease? What's the score that's right in the middle? So my kids in like 4th grade were taught, put them all out and then cross off the first one and the last one and cross off the second one and then the second to last one and sort of work your way into the middle. That's cute when you've got 9 scores. When you've got 243 scores, that's kind of a pain. Turns out that if you add 1 to the n and divide by 2, that is the number score that is in the middle. So in our data set, we have 243 observations. So if we say, what's 244, 243 plus 1, divided by 2, we want the 122nd observation. As I count down, as I pull down here, if you look up in the top right corner, oh, nope, so you see I've got 42 rows. Can you see that little yellow? So I want to count up, so I've ranked the data, it's all in order. I want the 122nd observation. Oh, wait, I've gone past it. So what is the 122nd observation? It is that 7 right there. So this is the mean. We think the median is 7. Let's see what Excel thinks the median is. So I'm going to ask Excel, and I can just say equals the median of this data set. What is the middlemost score? And Excel thinks it's 7.2. What a relief. I love it when Excel agrees with me. So the median is the middle score. We rank the data. We find the middle. We count up that many scores from the minimum. So if we have an odd sample size, in this case n equals 15, then we get 16 divided by 2 is 8. And we're going to count up 8, 1, 2, 3, 4, 5, 6, 7, 8. And there's the median. If we have an even sample size, guys, I've got 2 more minutes. If we have an even sample size, so now we've only got 14 scores. So 14 plus 1 divided by 2 is 7.5. So 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 7, 8, somewhere between those two. What are we going to do? Take the average of those two middle scores. And so in that case, we want somewhere in between those two. Those two are 5 and 7. We add those together and divide by 2 to get the average of 6, and the median is 6. The mode is the most frequent occurring. What's the mode in this data set? 9. It's the most frequently occurring. Oftentimes that will be right in the middle with the mean and the median. If there are 2 modes, no problem. We just call it bimodal or multimodal. We don't worry about there being more than 2 modes. If there are extreme outliers, the mean is really heavily influenced by outliers, but the median isn't. So in that case, we would go with the median as opposed to the mean. So the mean is very heavily influenced by outliers. Let's go ahead and have a look at our data. So this is our mean, right? If we'd left that -7 in there, well, that didn't bring it down. So let's do a really extreme outlier, -70. So that's brought our median down a huge amount. But it hasn't touched the median at all. But the mean is very influenced by outliers. So if there are outliers, then we are not going to be able to use the mean. All right, I will pick up there on Thursday. Thank you.